In this example, we want to write both a sine and cosine equation for the following information below. We know that the maximum occurs at pi over 2 comma 7 and a minimum occurs at 5 pi over 2 negative 3. I've already drawn some axes for you with some tick marks, so if you need to copy this down, please pause the video and write this down. I've picked the maximum to be at 7 here and the minimum at negative 3. I've also written 2 here because it's halfway between negative 3 and 7. Also, for my scale, notice we've got pi over 2 and another angle divided by 2, so I decided to make each tick mark worth pi over 2. We're going to plot some points, and we're going to start to reason then through our amplitude, period, phase shift, and vertical shift. At pi over 2, 7, that's where the maximum is. The minimum is at 5 pi over 2 negative 3. So here's negative 3, and there's 5 pi over 2. We now can draw our top line, bottom line, and midline. So the top line is going to go right through 7. The bottom line is going to go right here through negative 3. Oops, that'll be the bottom line. And then our midline is going to be halfway between. 7 plus negative 3 is 4, divided by 2 is 2. So you can find the average of the maximum and the minimum, and that'll give you the midline. The midline also gives us the value of k, or the vertical shift, which is positive 2. We can also tell now that the amplitude for this one is going to be 5. 7 minus 2, or the distance, the height between 7 and 2 is 5. You can also take the distance between, or the difference between, the maximum and the minimum y value and just divide that by 2, or find the average between the two of them. If we plot some more points, we have to use a little bit of reasoning skill here. So we've got 1 tick mark, and then at 5 tick marks the minimum occurs. So at 2 tick marks away, or half of that distance, we're going to have a point that's right in between. It appears that that's about 2 tick marks, or pi in this case. So we can go 2 tick marks to the right of the minimum, put another point, and we could even go 2 tick marks to the right and put another point here at 9 pi over 2. So this graph is going to look a little bit like this. We can now see that the period is from pi over 2 to 9 pi over 2. We can count the number of tick marks. 1, 2, 3, 4, 5, 6, 7, 8 tick marks. If every 2 tick marks is worth pi, that would correspond to 4 pi. So the period for this one is 4 pi, meaning b is 2 pi over the period, or 2 pi over 4 pi. So b is a half, same as the previous one. We want to start to write the equations here, and this is a special one where we're going to have to shift both the sine and the cosine. So let me draw you a sine curve. The sine curve would normally start here. At the first quarter, it's going to come up and hit the top line. At the second quarter, and this is without a phase shift, it's going to hit the midline, come back down at the third quarter and hit the bottom line, and then at the midline, it's going to come back and the y value will be the same as when it started. So here's what your sine curve is going to look like. I'll write that over here. That's our sine curve. And it appears that these are just out of phase a little bit, just shifted a little bit from each other. If we think about this, we want to think about how to move the one without the phase shift, so that's the blue curve, onto the red one. And that would be left by 1 tick mark, which is worth worth pi over 2. So when we write the sine equation, we know that our phase shift is going to be left pi over 2. When we write the equation then, we've got y is equal to, the amplitude is 5, and when we shift this over, this graph will start down first just like this one does, and so we don't need to reflect anything. We wouldn't want this point to be down here. We'll write the value of b, which is 1/2. You can write either x or theta here. The phase shift is left pi over 2, so we'll put plus pi over 2, close our parentheses, and then we'll write our k value, or our vertical shift, which is plus 2. For the next one, I'm going to graph you what a cosine curve would look like, and this is going to be without a shift. So the cosine curve would normally start at the top line. At the first quarter, it's going to hit the midline. Second quarter, it's going to come down, hit the bottom line. Third quarter, it's going to be back at the midline. And then it's going to wind up at the fourth quarter, or 4 pi in this case, that's the period, right where it started. So this is kind of like a purple or sort of a magenta color. So our question is, this is our cosine curve, how would we move the graph without the phase shift onto the one we want? So how would we move the purple one onto the red one? And the answer to this is all we need to do is take this point, or every point for that matter, and just shift every point to the right by 1 tick mark, which is pi over 2. So when we write the cosine curve, the only thing that's, or the cosine equation, the only thing that's going to be different is we've got to shift this one right by pi over 2. So we've got y is equal to, everything else is going to stay the same except this inside piece. And I want to write cosine here. This is right by pi over 2, so we need a negative sign and a pi over 2 inside. We'll close the parentheses and then put a plus 2.